Hello everyone, welcome to my YouTube channel. In this lecture, I am going to demonstrate the clinographic projection of the trapezohedron. Okay, trapezohedron basically consists of, it is composed of 24 trapezium-shaped faces. It is a closed form. It is belonging to the normal class of the cubic system, means garnet type, and each trapezium face intersect two crystallographic axes at equal distance and third at a different unit. Basically, one axis, each trapezium intersect one axis at twice unit distance and other two at the twice distance. So that's why the general symbol of this model is HKK and unit symbol is 211. This trapezohedron consists of what? 24 trapezium shaped faces, and also it is belonging to what? Normal class. So if it is a Gardner type, a normal class, then it will show what? Nine plane of symmetry, a mirror plane, and 13 axis of symmetry, and center of symmetry will be present. Now I am going to discuss the symmetry element. Okay, regarding symmetry element, you can see different type of faces. It is easily visible, and you can recognize these four. So it is made up of what? 4x trapezium shaped faces. These are 4 trapezium shaped faces, and each are showing that these two are of same length. Okay, and these two are same length. So you can see this is the front face. Okay, what you are saying, same face is on PPT also. So you can easily recognize these two sides are of equal length, and these two sides are of equal length. This is the special kind of the trapezium. So I am just drawn the red line. This red line represents the one arm. You can easily see that same length is to other one. Likewise, similarly, the yellow line represents this side of the trapezium, and the same length will be recorded in this side also. So you can easily see, you can easily find it that trapezium is made up of 4 sides. You can see these two sides are of equal length, this and this one, and this one of equal length. Okay, so these two sides of equal length, again in here this side. So this face is, you can see, this is made up of 4 trapezium, and this common point is a point where 4 trapezium of the longer length sides. So this is the a junction of the 4 trapezium where length of the sides are longer in comparison to these two. So one is such kind of junction. Second is this one, where here also 4 trapezium face of meeting, but this point is showing two are larger. Okay, you are getting two larger, longer length side and two shorter length sides. So here all 4 are the longer length sides are meeting, here two longer and two shorter edge are meeting. Okay, again you can see this point, third one, where 3 equal length sides are meeting and it is shorter edge sides 3. So why I am telling it? Because when you will hold from this where longer sides are meeting at a junction, these are the crystallographic axes. Okay, you will hold from this, you will get the fourfold symmetry. How many? Fourfold. Okay, holding a point where four longer sides are meeting, okay, you will get fourfold symmetry. This one you can, how, this one first, rotate 90 second, rotate 90 third, and rotate 90 this one fourth one. Okay, now again you can rotate like this, you will get same kind of the symmetry element, and you can rotate like this, you will get same kind of symmetry elements. So these are the, where the four longer sides are meeting, these are showing the fourfold symmetry. Now hold from this point where two longer side and two shorter sides are meeting a point like this. So you will get how many? 1, 2, 3, and 4. Corresponding to this, I am holding from here. You can count same the below and same 1 and 2 and 1 and 2. It means there are 12 such kind of points where four sides are meeting, and of which two are longer in length and two are shorter in length. Okay, so this point is, you have how many? Total 12. How? 1, 2, 3, 4, and this one 5, 6. Okay, again here and here. So total, this is only showing front face, it is, so you will get total 6 in this, you can see. So holding this, I am holding from it just opposite downward. Okay, now see, try to see, consider these faces. When you will rotate, same kind of face will come? No, because this showing some kind of, you can say this is triangular, this, and when you will rotate, you will get some this kind of faces. Okay, but when again you will rotate, you will get same kind of faces. Okay, so these are showing twofold of symmetry. So there are 6 such kind of axes which are showing twofold symmetry. These are the diagonal ones. Okay, now hold from this point where 3 shorter edges are meeting. Okay, length of the shorter edge. So hold it from it. You can hold. You will get 3. This 3 is showing that these are the points from where you will get how many? Threefold, because you will rotate only these three face will be repeated. Okay, so these will showing threefold, and such kind of how many? Total 8 points are such kind. 1 here, 2 here, 3 and here 4, and 4 will be opposite direction. That is in bike direction. When you will make the bike faces, then you will get the 4 points. So from holding these points, you will get how many? Threefold symmetry. So total, how many is there? 3 axes of fourfold symmetry, 4 axes of threefold symmetry, and 6 axes of twofold symmetry. In total, there is 13 axes of symmetry. Now plane. So similar to the cube, you have 3 mirror planes along the crystallographic axis. Okay, and 6 mirror planes along these points. Mineral crystallizes in this system is garnet, as it is type of garnet, and lucite. Now I am moving to Clinographic projection. Before I will start the clinographic projection of this trapezohedron, I think you have watched preparation and drawing of the axis of the cubic system. If you have not watched it, so just go to playlist of my YouTube channel and first watch the preparation and drawing of the cubic system, because I am going to start from the axis of the cubic system. First, draw the axis of the cubic system required in clinographic projection, where this this is the A1 axis, this one is A2 axis, and this one is the A3 axis. This one is the positive end of A1 axis, this one is the negative end of A1 axis, this one is the positive end of the A2 axis, this one is the negative end of the A2 axis, and this is the positive end of the A3 axis, and this one is the negative end of the A3 axis. Yes. So I am going to rename it for the positive A1 A, and for negative end of A1 B. Similarly, for the positive end of the A2 axis C and negative end of the A2 axis is D. Similarly, positive end of the A3 axis E and negative end of the A3 axis is F. So now again we have to determine the midpoint of the positive, negative sides of the all axes. So if you do not know how to determine the midpoint of any line, okay, without measuring it using compass, so you must watch the exercise, I think, in tetrahexahedron and trisectahedron, and also I think in tetrahedron I have demonstrated the procedure for the making midpoint of the a line using only the compass, so you can watch there. But here I am going directly to mark the midpoint of the positive and negative sides of the each axis. It means the midpoint of OC, midpoint of OD, midpoint of OA, midpoint of OB, midpoint of OE, and midpoint of OF. That's why I am saying positive part of the. So if I say this here, it is also a positive end of the A1 axis. So from this intersection where all three axes are intersecting each other, from this point towards A is this is the positive side of the A1 axis, and from this side will be negative part of the A1 axis. So we have to mark the midpoint in both side, positive side and negative side of the axis. Okay, so mark it. So these uh, I, J, G, H, K, L, these are the midpoints of A2, A1, and A3 axis respectively. In next step, what we are going to do? We are going to do joining these midpoints from the end point of the axis. So it means it is the midpoint of A2 axis. So it is already in the same line where A2 axis is going. So it means we have to join this midpoint from the A3 axis and both end of A3 axis and both end of the A1 axis. So a midpoint of any end of the positive or negative end of the axis will be joined with the other endpoints of the other two axes. Okay, remember it. Second thing, we will only join the positive side of the A1 axis, means only A and G. We will not going to use H and B, because we are going to first draw the front side of the trapezohedron. Okay, so For that, we will only use the positive side of the A1 axis and A3 and A2 axis, both side positive and negative. So, and all these lines are the construction lines. So you have to draw very light and very thin. Okay. So let's start. First, join A from the all four midpoints of the A1 and A2 axis, and midpoint of the positive A1 axis, that is G, through the endpoints of the positive and negative ends of the A1 and A2 and A3 axis. So these are the lines. Green ones are the joining A from the midpoint of the all four midpoint of the A1 and A2 axis. These green lines are joining the midpoint of the A1 and A2 axis, and the lines starting from the G are joining the endpoints of the A1 and A2 and A3 axis. Okay. In next step, we have to draw the same procedure for the A1, A2 and A3, means from the end of the A2 axis to the midpoint of the A3 axis, and from the midpoint of the A2 to end of the A3. So these 4 points are the intersection point of the A1, A1 in the points of the A1 and midpoints of the A1 axis. These four are derived, and another 4 points are derived by only joining the midpoints of the A2 axis and A3 axis. So name it also. So now we have 8 points. These points are PQ, RS, PQ, RS, and TU, VW. These 8 points are intersection of the lines which are joining midpoint of one axis and end point of another axis. Okay, and we are using only positive ends of the A1 axis. Remember it. So now we are going to join these midpoints derived in the last step, 8 points, from the end of the all three axes, end point of the all three axes. I am going to join first A1 positive, that is A, to all 4 point T, U, V, and W. In next step, I am going to join these PQ, RS from the PQ with the endpoints of the A3 axis and RS with the endpoint of the A2 axis. So RS with the endpoint of the A2 axis. Now PQ with the end of the A3 axis. So again we get 4 points. All three lines are intersecting at same place, and we are getting 4 intersection points. Okay, so these points are PRT, QRU, QSW, and PSV. Now why I'm naming it like PRT, QRU, QSW, and PSV? You can see from this point there are how many lines? 1, 2, 3, 4, 5, 6. Total 6 lines are emerging from the, you can say the 6 ray are emerging from this point. from each points 6 rays are emerging. But for the drawing of the trapezohedron outline, only 3 lines are the important. Okay, these lines joining the points P, R and T. Okay, that's why this point is named as PRT. 3 trapezohedrons are joining and 3 edges are generated, and all 3 edges are of equal length. Okay, so these are the point which was the name as PRT as QSW or QURT or PSV. These 4 points. So these front 4 points, then you have back 4 points. Okay, and joining these will what will show threefold of symmetry. So only we have to join from, so from this PRT you have to join part point P, P, point T and point R, only 3 points. Okay, and similarly from Q you have to join U, R and Q. Similarly from here you have to join Q, S and W, and from this point you have to join P, S and V. And another outlines are the, how many we get? 3 here, 3 here, 3. So total 12 line you have to, these 12 lines you have to mark as dark or the outlines. Okay, next these like K2U, U2J, J2W, W2L, L2V, V2I, I2T and T2K. This is the outmost outline of the front face of the trapezohedron, and this edge will be common in back end and front end. So first draw it. When you will join these 4 points, I am told you, like PRT to P and T and R. So when you will join this point with P and P and R, you join like this. Again you will join this. So you will get a similar to this outer outline. You get an inner out outline. Okay, inner outline. So and then you have to draw this PRT point to T, QRU to U, QSW to Q and S, PSV to S and V, and this P to I, S to L, Q to J, R to K, and these all points are Q, S, P to the G. So let's start drawing the outlines of the front face. This is the outmost line, then this is the innermost one, and then you have drawn the faces of the trapezohedron. Okay, the blue ones are showing the outline of the front face of the trapezohedrons. So front face part is completed. In exercise, for if you are not going to do so much of work, it is sufficient to learn how to draw the clinographic projection of the trapezohedron if you can draw only the front face. No one is bothering about, no one will say why you have not made the bike faces, because you know here for the making front face so much of line you have drawn. So for the bike end only these 4 points, that qt qt no tu wv will be common. Otherwise you have to generate this point pqrs and this three fold points, that is prtq QRU and QSW and PSV. So there are a lot of work remains for the Vikings. So only drawing the front face will be sufficient for the trapezohedrons. Now I am going to first discuss the Miller indices of the faces. Okay, I will discuss one or two face. Before that, I am going to remove the constructions lines, but I will keep some green and some red line with R, P, R, T, P and G. So this face intersects clearly one axis, you can say at A1 axis at point G. Okay, so and one more thing, this OG is 1 unit and OA will be 2 units. Similarly, O to A is the equal to the distance between O to G in cubic system, because all three axes are of equal length, so their midpoints will be also of the same length. It is showing that midpoints distance of OG is much greater than the OA. This is only due to the perspective, and another way this is only in clinographic when we are transferring from a 3D model to the 2D. Okay, but actually OG, OE, OJ, OK and OL, OH all are of same length, and similarly OD, OC, OA, OB, OE, OF are of the same length. This face GRPRTP, this one is intersecting A1 positive axis at unit distance, but you can see this is the this line is parallel, face is parallel to which line? This OGE. It is parallel to this edge of this face. The edge GR is parallel to what? GE, and GE is intersecting the A3 axis at twice unit of the edge comparison to the A1 axis. Similarly, the edge GP is intersecting A2 axis at twice unit in comparison to A1 axis, because this GP is parallel to the line GC. So you can say this face is intersecting all three axes and A1 axis at unit distance, A2 and A3 axis at twice distance. So which symbol will be 1 by 1, 1 by 2 and 1 by 2, and Miller indices will be 2, 1, 1. So this face will have Miller indices 2, 1, 1. Similarly, for the R, Q, R, U, G and Q, just adjacent to this face. Okay, here the similar situation, it intercepting A1 axis at unit distance and A3 positive end at twice distance and A2 negative end at twice distance. So this Miller indices will be of this phase will be 2, 1 bar 1. Now I am going to take this phase. Which one? RKT PRT. RK T, PRT. So these faces intercepting A3 axis positive side at unit distance, and this line or edge K are each parallel to which one? KA. So it is intercepting, this face intercepting A2 or A1 axis at twice distance. Similarly, this KT is parallel to KC. It is also intercepting this face A2 positive end at twice distance. So Miller indices will be what? 1, 1, 2. Just opposite to, looks like just opposite of this face. Here it is 2, 1, 1. Here it is 1, 1, 2. I am going to demonstrate the drawing of the bike faces also. So I will remove all the constructions line except the lines joining are the lines which are making point TU WV. Okay, and all other lines will be removed. Front face will be removed and this intersection point will be removed. So these 4 points will be required in back face also. So these points are kept here. Now start joining from the midpoint of the negative end of the A1 to the A2 and A3 axis endpoints, midpoints and endpoints both. So we get again 4 intersection points, 1, 2, 3 and 4. These are the similar to the front one, P, Q, R, S with subscript as B. That's why it is PB, QB, RB and SB, because these are the bike faces. So dotted line also showing that we are constructing the bike faces of the trapezohedron. So again we have to do, again we will join the end points of the axis with the intersection, 8 intersection points, that is Q, PB, QB, RB, SB and TU, VW. Okay, so TU, VW will be joined from the point B, and again these 4 points RB and SB will be joined with the endpoints of the A2 axis. I joined the PB and QB with the points of the A3 axis. Now RB and SB with the endpoints of the A2 axis. So again we will get what? 4 points here, and this is the again similar to the points, that is PRT, QUR. So again we have to name it. So here the naming is same, but these are the small letters only. Now start joining. This is the outermost, then innermost. You will get innermost. Now join these points. Which one? RB, QB, PB and S with the midpoint of the negative A1 axis, that is H. So join it first from the H and now outer. So this is the back face of the trapezohedron. Now I am going to draw the front face of the trapezohedron and removing the other lines. So this is the Picture showing all 24 trapezium faces of the trapezohedron. You can count it. The colored faces are the front faces and the shown with the dotted lines are the back faces. So drawing of the clinographic projection of the trapezohedron is completed. Thank you.